Only one planet has the potential to offer us a fresh start: Mars. The red planet has long been a target for extraplanetary colonization due to its size and proximity to Earth.
Ignition.
The first potential hurdle to colonization is getting there. NASA will have the first spacecraft capable of making a crewed journey to Mars within the next decade, the Space Launch System. However, it may not be enough for actual Martian colonization efforts. It would need special radiation shielding to protect it from the cosmic rays it'll be bombarded with on the 9-month-long journey. It's believed that a single trip to Mars will see astronauts receive the equivalent amount of radiation they'll be exposed to throughout their entire lifetime. Not only will this increase their risk of cancer, but it may also interfere with their reproductive systems. In general, space travel causes a variety of stress-like responses, many of which affect the genome itself, as well as the immune system. All of this would put an end to any plans of colonizing Mars before we even get there. There are a couple of ideas in play for shielding astronauts from cosmic radiation. For instance, certain compounds are believed to be especially resistant to radiation, such as lithium hydride. It hasn't been properly tested on spacecraft yet, so let's say the timeline of developing, testing, and rolling it out may take around 20 years. The first thing astronauts will need to be able to do to begin colonization efforts is to establish renewable sources of air, water, food, and energy on the alien land. This will be their only hope for survival, as supplies from their ship won't last forever. So how would we go about making Mars' atmosphere breathable and suitable for terrestrial life? Surprisingly, the answer just might be robots. In April 2021, the Perseverance rover was able to successfully produce oxygen on Mars' surface thanks to its MOXIE instrument. This is a small device capable of producing oxygen from atmospheric carbon dioxide through a process called solid oxide electrolysis. It was able to generate roughly enough oxygen to sustain one person for about 10 minutes, almost as much as what's produced by a small tree here on Earth. Since the tech exists, it's only a matter of scaling it up for our space colonization needs. In theory, we should be able to use MOXIEs as stand-ins for trees in the near future. Just like on the ISS, it's expected that the spacecraft will be fitted with an efficient water recycling system. This gives astronauts a bit more leeway as they probe Mars' surface for potential sources. Evidence suggests that Mars' surface was once covered in oceans, lakes, and rivers of water similar to ours. Researchers even discovered what they believe is a subglacial lake, 0.93 miles below its southern polar ice cap. Still, it would take a significant Martian development project to access it. That's 20 years of progress before this is feasible. Matt Damon may have been onto something in The Martian, but in reality, we don't know for sure if we'll be able to yield any crops on Martian soil. Scientists are optimistic, though. This is thanks to the composition of the planet's upper crust. It contains many of the nutrients plants need to grow and survive, such as nitrogen, potassium, and phosphorus. Despite the optimism, we won't know for sure until we actually try. The red soil may contain toxins that would make any food grown there poisonous. Barring this possibility, as soon as we sort out our oxygen supply there, Martian agriculture may be possible. At the very least, we may be able to hunker down and start gathering materials for building Martian infrastructure straight away. With the right equipment, the planet's rocks can be used to shield astronauts from radiation as they search for resources such as water, metals, or minerals. All the steps to establishing a colony on Mars are perfectly possible, even if they're conjecture.